this is the equipment. Yeah. Okay. This all the equipment here. This is the computer. This is the power for the device, LED or laser or something else. This is the power, and this is the spectrometer. Yeah, spectrometer, and this one is the integrating sphere. We will use this. Yeah, it connected with each other, and all the equipment connected with the PC. Okay. Actually, the measurement is very simple, so you can remember it. Okay. First, before get started, we should turn on these two equipment. The spectrometer, just click here. This is the power, and for this, the power supply, we just click here. We don't need to set it. Just click one time. Okay. Yeah, it's very simple. And here is the sample holder.
For what?
For the packaged samples, we can see here. Because the measurement should be done in the integrated field, so the sample should be holder in this, and we put the sample in the spheres, and this is the sample. And for this equipment, we can only measurement the packaged sample. We can see here. For the white one, the white color, you can see. This one is aluminum plate. Aluminum plate is a metal aluminum. It's used to increase the thermal transport. Yes, to make sure the temperature can transport very well. And the yellow one is the package, and for the LED chip, we can see here in the center there are very small LED chip in the center, and yes, when we fabricate LED chip, we need to separate it and put it in the package, and then use the golden wire bonding to lead out the electron of the device. For the golden wire bonding, we can do this in the clean room. They have the equipment, but if we want to attach the package on the aluminum plate.
So this aluminum is like aluminum plate is like heat sink, like how it's maintaining the temperature of the whole package.
Oh yeah. Usually, so for some device, when we give a very high current, the device will the junction temperature will be very higher. Yeah. So the device will be not very stable, right? And by use this thermal dissipation, yes.
Dissipation.
Yeah, dissipation. It will control the temperature, and the next temperature decrease. But for this sample holder, we didn't have a fan in here, so we can't control the temperature of this device. But they in this company, they have a sample holder which have the fan and to use to decrease the temperature. Yes.
So what is written? Okay.
Yeah, it's Chinese. Yes, it's a very simple one here. Yes. So we can do the golden wire bonding in the coaster, but we cannot do it. Cannot to attach the package on the aluminum plate, but we can do it in China. We can send the sample to China and send it back. Yes, it's also very fast if you want.
So if I have a LED device, then I have to wire bond. Take this. We have this various different kind of this, right?
Yeah.
So we will wire bond and keep it here. Put it here.
Yes.
Okay.
The wire bonding is in this package. Yeah. very
so
small.
we have a lot of such packets, right, for different LED. It is not reused, right?
Yes,
Because
yes.
it's already wire bonded.
Yes, have different package. Yeah. Okay. After we get this, we should connect the device with the holder, and this is the positive and the negative, and should make it right. Okay. We can see also in this plate it also have the positive and the negative, and we can make it right, connected. Okay, it's connected, and put the sample in the integrated field. Okay, now the device is ready. Next is the software. This is the software. This is the software we will use. Is the MFI named. We can click yes. And for this equipment, there are two different test models. One is the normal one, and another is a pulse test model. The normal one means that we will give a continuous current on the device. The operation of these two models is completely the same, and so I just will show you one of it. Is the normal one. When we open this software, it will connect with these two equipment, so we need to wait a few seconds. After this, we should give the setting, and we can see here. IF is the calendar forward. So, yeah, IF is the calendar forward. Is because LED is a current device, right? We should give the current. So here we just give the current, and this one, yeah. Yes, here we can type in the current, and the unit is microampere. Now we typed in 50, so it's 50 microampere here.
The unit is fixed?
No, it's not fixed. We can change it, 10 or anything you want. Now I just give you an example. Okay, this is the maximum wattage. This wattage is used to save the device to not let it break down or something else. Yeah. And for the preheating, preheating is I just said to you, if you give a big current, the device will heating. So the optical power of this device will not stable. So we should give a preheating time to make it stable. Just wait. Such as we give 1000 microsecond, and this device will keep the current and for 1000 microseconds, and wait heat stable. So usually you also don't need to set this. You can just give the current and wait, and don't need to set this. And this is the integrating time. For this one, usually we use the automatically, and if the light intensity of your device is very, very small, you can use it manually. Give a very big integrating time, and yeah. And this the set we see here. There are two different model we can use. The first one is the fast tester. Fast tester usually it means we will measure this device in a very short time, and the accuracy of the tester is very easy enough actually. But in another case, if a device is very weak and the light is weak, you can use the precise use these models, you can get a very sensitive result. Okay, and for the refrigeration, and it's just for the sample holder which have the fun, so we don't need it. We just turn off it. It's okay. Now we can click OK. For the range, actually it's the same, so we don't need to change it. For the parameter, for this parameter is just the software used to judge if the device is working or not. Yes, if the device is not working, the optical power or flux will be 0, right? So they just want to choose the parameter to judge the state of the device. So fleximer or other parameter also will be the same. Okay. Now after the setting is ready, we can do the measurement. It's very simple. First, click the fast test. So then we can see the test button is highlight, and yeah. First, click the fast test. Yes. Before we click it, we can see we can click this test button, but after we click it, the button will be highlight, will be bright, and after that, just click the test. Yeah. Yes. Just click. It will be start. Now you can see the current in the power is 50 microampere. Right. Okay. It finished. Very fast.
Yeah.
Okay. Okay. This is the test result in here.
All these are test result or only one line?
Only one line.
The last one usually?
Yeah, the last one is the result we just do it. And before that, we also do lots of measurement. We can see here, from 0 to 45. There are different current. We can see the current is increased, and even 1000 microampere. And this is the result. Okay. In this table, we also have very important information. Also another information, such as color ordinately, and the color temperature, and the peak wavelength. We can see the peak wavelength, and also the HDMS. I don't know what's the name. Yeah. And also another, but most of this parameter is used for the white LED. For the UV LED or blue LED, and such as color temperature or color ordinator is not very important. Okay. The last thing is how to export the date. You can see, you can click here first. First, we need to export the date in these tables. Just click the file and export files. Links here, and then will pump up this window. And in the user, you can type in your name, and such as I use my name.